we have been discussing about this biomimicking related propulsion. So we had discussed about various types of biomimicking related propulsions. We have been discussing about this like E. coli based biomedical propulsion, bacterial based biomedical propulsion. In fact, it has a potential application towards this targeted drug delivery. So in all these cases, so the actuation is based on so either it might be through magnetic or it might be through pressures, or in some cases it might be through chemical reactions also. Okay, so in this series, so algae based or algae inspired micro robots are considered to be one of the domain where there is quite a good amount of potential is there, and most important aspect is these kind of algae based micro robot has a potential application towards drug delivery and other biomedical related areas. So as far as these algae inspired micro robots are concerned, they have attracted an intense research over the past decade owing to the abundant desired properties of natural microalgae, such as biocompatibility, autofluorescence, pharmaceutical activity, which make them an ideal candidate for biomedical and related applications. With the deepening and widening of applied research, the function of these algae-inspired micro-robots have been greatly enriched and enhanced to meet the needs of demanding application scenarios, including the targeted drug delivery, anti-cancer, antibacterial therapy, cell simulation, wound healing, and biomolecule sensing. So, notwithstanding, it also has a multiple challenges remain to be tackled for transformative advances and the clinical translation. Now, as far as these algae-based micro-robots are concerned, so these algae-based micro-robots are classified into three different types of category. One is called as a microalgae flagellated robots. So as far as these microalgae flagellated robots are concerned, so these are some of the varieties of these microalgae flagellated robots. And as far as manufacturing of these microalgae flagellated robot perspective point of view, these microalgae flagellated robots are like either manufactured through biotin, streptavidin binding, or through electrostatic interaction, or sometimes there is a concept called click chemistry. Okay, so with reference to application perspective point of view, so they have a potential application in micromanipulation, they have a potential application in active drug delivery, anti-cancer therapy, antibacterial therapy, a biological detoxification, on-cell enzyme catalysis, and wound healing. With reference to functional perspective point of view, it works on the functionality related to photoaxis, magnetoaxis, photodynamics, photothermal, biocompatibility, degradability, oxygen generation, and immunoregulation. Now, with reference to microalgae hybrid robot perspective point of view, we have a certain series of such kind of microalgae hybrid robots which are being successfully deployed. So one is a kind of calmadonomous based structures. So if we try to look into the manufacturing perspective point of view, so it can be manufactured through simple techniques like dip coating, soldier electrolysis deposition, surface polymerization, and electrostatic interaction. With respect to function perspective point of view, drug loading and release, off and on fluorescence sensing, enhanced photothermal, selective cytotoxicity, tunable biodegradability, piezoelectric effect, and optohydrodynamic effect. So with reference to application perspective point of view, it is widely used in active drug delivery, anti-cancer therapy, antibacterial therapy, disease diagnostics, cell stimulation, and biological detoxification. When we consider this, there is another set of microalgae which are being effectively used for micro-robotic related application, which we call it as a microalgae templated robot. So these microalgae templated robots are concerned, they are called, there is a kind of diatoms base which are available. So with reference to manufacturing perspective point of view, biomineralization, annealing treatment, physical vapor deposition, and electrostatic interaction are considered to be some of the key manufacturing techniques which catered this microalgae templated robot. With reference to function perspective point of view, it has a high payload capacity, it has a photothermal effect, it has quite a good amount of remote biosensing and heavy metal ion absorption. And as far as application perspective point of view, it is widely used for active drug delivery, antibacterial therapy, biological detoxification, and biomolecule detection are some of the key areas where these algae are being effectively used. Now, let us see the type of algae and its overall construction of this algae. First, let us discuss about this microalgae based hybrid robot. So, this microalgae based hybrid robot are a kind of a non-living biohybrid algae with optional functional modification and algae surface or within the cells. The morphological structure and the biological substance of the microalgae will be preserved, but the cell activity is forfeited. So, with externally coated materials, most of these it acts as a kind of a surface anchor, or in some cases it also acts as a kind of a antibiotic structures. So, these with externally coated materials, mostly magnetic substance like Fe3O4 nanoparticles, it is possible to confer magnetic attributes to the microalgae for remote actuation and steering using magnetic field. These magnetic microalgae hybrid robots are versatile in varying scenarios because they can perform complex tasks even in harsh environment and toxic environment. Additionally, the biological compound inherited from a microalgae cell can equip MHR with desired functionalities such as autofluorescence, magnetic resonance signal, and anti-cancer activity. Through integration of additional components, other functions such as photoacoustic imaging, and antibacterial therapy can be achieved, enabled by a polydopamine. So, benefiting from diverse functionalization strategies, these microalgae hybrid robots can be customized to accommodate a plethora of functions in a single package suiting the target applications. When choosing these chemical compositions of these microalgae hybrid robots for in vivo applications, there are some crucial aspects which including their cytotoxicity, their biodegradation, imaging capability, and potential immune response should be considered whenever we are trying to look into these kind of microalgae based system. Now, if you closely observe in this microalgae based system, microalgae hybrid robotic system, so we have the kind of a payload which will be integrated along with the system, and the other one is a kind of a anchor which is used for reaching a particular target and to stick on to the particular target and diffuse the medicine or the biocompatibility drugs etc. will be taken care by this anchor component. Now, in similar fashion, so when we try to talk about this such kind of microalgae based templated robot, so this is ideally the structure of these microalgae based template robots. So in these structure, so if you see there are wide varieties of strokes are there. So wherever we need to have a forward stroke of algae, so there are some kind of tentacle kinds of structures which are there. These tentacle kind of structures are effectively used for an appropriate propulsion. Whereas if we need to have a reverse stroke, so appropriately these tentacle structures are reversed to create a reverse stroke. So in this particular case, so for example, if you take a forward stroke of an algae, so the 1 to 7 will be helpful for giving a forward stroke. Wherever there is a reverse stroke is there, so the sequence from 8 to 11 or the tentacles from 8 to 11 will be involved in such kind of reverse stroke. So as far as these microalgae templated robots are concerned, so these microalgae are defined as a synthetic micro robot merely replicating the microalgal morphology with both structural matrix and contained compound removed after fabrication. These microalgae templated robots rely on electrochemical deposition process in the sense that the microalgae mainly provide a biological template for shaping the micro robot regardless of their cell activity and intrinsic functionalities, which are eventually eliminated. Owing to the internal cavity space freed during the fabrication procedures, example through annealing treatment. A large quantity of molecules or drug payload can be loaded in such kind of microalgae templated robots. So these microalgae templated robots are mainly meant for targeted drug delivery and controlled release. So during the fabrication process, the microalgae structure is susceptible to excessive damage, potentially affecting the locomotion performance of these MTRs. Therefore, factors such as temperature and reaction time needs to be precisely controlled to preserve these microalgae based morphology. Now, when we look into the overall manufacturing methods which are involved in such kind of these things are concerned, microalgae based structures are concerned, there are two important aspects which we may need to look into it. One is they should have a capability to swim in the fluid environments and glide on the surface with continuously propulsive force generated to empower the locomotion. When we try to consider the second part, they need to demonstrate a certain tropism for controllable steering motion towards targeted location. Okay, so as far as these kind of things are concerned, so these are meant for enabling MFRs to desiccate the functionality, to desiccated functionalities, various strategies to modify the microalgal surface with exogenous materials. Okay, so such kind of microstructures, there are different types of microstructures which exhibits. So in most of these cases, such kind of microalgae are grown through a kind of like a cell kind of structure or through chemical systems, so that it can be used for, it can be decorator or it can be like integrated with such kind of structures. So as far as in this microalgae is concerned, so we have a kind of an electrostatic interaction and then there is a magnetic microbead. If you closely observe in this, so as I discussed earlier, so in order to have an appropriate propulsion, there is a need to decorate these structures with appropriate elements, so that when we try to give a kind of like actuation to these elements, so these elements will be capable enough for a appropriate locomotion. So in this particular case is concerned, this is the overall microalgae. In this overall microalgae, these entire microalgae is decorated using a kind of a magnetic microbead. So these magnetic microbead are appropriately actuated using this electrostatic interaction. So that is like through a kind of a charge, so which can be used for a micropropulsive action. So as far as in this micropropulsive action is concerned, so we have a microalgae, then there is going to be a magnetic microbead. So with the integration of this microalgae and a microbead, finally we get a micro robot which exhibits over here. So these are some of the different examples or the different class of algae based micro robots, which also has a potential application towards drug delivery. However, this area is not much explored. So just to give you an overview, I thought that I will just explain you these basic concepts. Now, when we try to look into the theoretical aspect perspective point of view, so whenever we are trying to design such kind of bio-inspired micro robots, so as we have discussed earlier, so we need to have a very low Reynolds number, less than 1. So let us see what are the different parameters which basically tries to participate with reference to such kind of lower Reynolds number structures, with reference to these bio-inspired micro robot. One is a low Reynolds number hydrodynamic, which we call it as a Stokes flow. Since micro scale robots operate at Reynolds number less than 1, the Navier-Stokes equation can be written is considered. So here, if you closely observe, so we have the fluid viscosity in place, we have the P pressure in place, U is the velocity. Since the inertia is negligible, the movement must be a non-reciprocal. In fact, it is governed by this Purcell-Scallop theorem. Okay. Now, the next aspect, so this is with the reference to the fluid domain perspective point of view. Next is with the reference to the flagellar motion. So if you observe that we had a kind of a flagellar whip, through the flagellar whip, so there is a kind of a huge frequency is getting generated, which is helpful for the appropriate locomotion. So if you look into the resistive force theory for this flagellar motion, it is basically decided by the resistance coefficient, the velocity component, which are normal and parallel to the flagellum. So these resistance coefficient, these velocity component, and these system will get participated in this particular structure for appropriate movement. Now, when we try to look into the helical propulsion model for magnetically actuated similar perspective point of view, so we have the rotation frequency which is participating in this, R is the helical radius, lambda is the wavelength, and then theta is the helix angle, which is used for an appropriate participation. Okay, so the overall equation is governed by these parameters to get a particular value. Now, when we try to look into the jet propulsion model, we have a kind of a jellyfish inspired motion. So the thrust generated by the expelled fluid volume V is F thrust equals rho V dV jet by dt. So V jet is the kind of a jet velocity. Rho is a kind of a fluid density which is being effectively used. So here in this particular case, we have discussed about the parameters involved in the helical propulsion and the parameters which are involved in the jet propulsion method. Now when we try to consider the surface walking and the rolling, so for a rolling robot, the force balance include the adhesion and the rolling resistance. So the F propulsion basically includes, it is in the order of micronewton with F resistance. Micro is the friction coefficient, N is the normal force, F is the resistance which includes the van der Waals force for the adhesion. Now let me just introduce you. So till now we have been discussing most of the cases on a micron level. So one of the methodology or one of the module is towards this water running robot. So as far as in this water running robot is concerned, like basilic lizard is considered to be one of the key creature, so through which we can just extract some amount of mechanism which caters the need for this water running robot. So as far as these water running robots are concerned, so it's a kind of a small lightweight animal, have a large variety of flotation mechanism which is open to them. So there are spiders and insects with float using a kind of a surface tension. They propel themselves using a meniscus in water and because of the maragonic flow. So larger animals have few options. Lizards, aquatic birds and marine mammals with their larger bulk and higher masses, they utilize buoyancy, viscous drag and the momentum transfer. So as far as these kind of basilisk lizards are concerned, it is capable of running across the surface of water at approximately 1.5 meter per second and a stepping rate of, like, if I try to tabulate the overall characteristics of it, like the running speed is on the water surface 1.5 meter per second and the stepping rate is 5 to 10 hertz. Okay. There are four factors which influences the lizard ability to stay afloat. One is the body mass, second is the characteristics length, third is the running speed, Fourth is the shape of the foot. So all of these variables are interrelated, and the morphological relation to the lizard's water running are being considered for different applications. Now, as far as these lizard based water running is concerned, there are different phases which exhibits. So some of the phases basically includes the slap phase, stroke phase, recovery up, and recovery down. Okay, so what do you mean by this slap phase? So let us consider this as this basilic lizard. So in this basilic lizard, when it wants to move on the surface, what does it try? It tries to maintain an equilibrium on top of the surface. Then there will be a kind of a slap phase which exhibits over here, and then with reference to a slap phase, so it will try to move on a stroke phase, and then this is a kind of a stroke phase, and then again it will try to come up with a recovery up and a recovery down. So if I try to if I try to represent it in the form of a small figure, so this is a kind of a slap phase. So in this slap phase, this lizard is going to rest like this, and then in the stroke phase, this is going to push in this direction, in the recovery up, and in the recovery down. So all these corresponds to the foot motion. Okay, so in order to have a better understanding on this slap phase and the stroke phase and the recovery up, let us see some of the key parameters which are involved with reference to this slap phase and the recovery phase. Now, as far as these slap phases are concerned, so during the each step on the water, an initial slap at the interface pushes on the basilic foot. So for younger, lighter lizard, this slap phase can provide all of the lift necessary to stay afloat. The lizard's ability to generate excess lift during the slap phase of the stroke declines as the mass of the lizard increases. So the slap phase begins when the foot first contact the water. Foot motion is primarily downward, and the magnitude of the upward force is much greater than anywhere else in the step. So the maximum slap impulse which we call it as Imax slap, which is a function of effective radius of the foot which we refer it as REFF. The peak velocity during the slap U peak is Imax slap, which is equals 4/3 R cube EFF U peak. And when we try to consider the stroke phase, this is a kind of a slap phase. So as far as these stroke phases are concerned, after the slap phase, the lizard pushes against the water beneath its foot. So stroking downward and creating an air cavity in the water, the momentum transfer from the lizard foot to the water during this force stroke phase generate the rest of the lift force necessary to stay afloat most of the forward thrust. So while basilisk lizard do apply a significant force to the water in a lateral fashion, it is felt that this is done for balance and stabilization and not for lift. Or this lateral motion may be anatomically limitation imposed by the created posture. So for heavier lizards, most of the lift comes from the stroke phase. The drag on the foot is the combination of the hydrostatic drag due to increase in depth so we can represent something like this. D of t equals CD star 0.5 S rho u squared plus S rho GHT. D of t is the time varying drag force. CD is the constant drag coefficient. And G is the acceleration due to gravity. So we can represent it as S equals pi R squared E effective is the area over which this drag is occurring, and H of t is the time varying depth along the foot. Now when we try to consider this recovery up and recovery down, so when pulling its foot out of the water during the recovery up phase, the basilisk lizard will curl and the toe inward, so as shown over here. To prevent the accidental drag on the cavity walls, this takes place entirely within the air cavity and must be completed before the cavity collapses. So during recovery down, the speed of the stride increases as the lizard prepares to slap the water surface in the next stride. So no significant forces are experienced by the lizard foot in either of these phases. Now in this particular aspect, timing is considered to be one of the important parameters. So if you consider the timing, so the period of the time, which is nothing but the cavity is open, which we call it as T seal. So this T seal basically depends upon the shape of the foot of the lizard. So for circular disc, the relationship is 2.285 RF by G root of G. Is the period set for an absolute minimum frequency, the lizard must slap down, stroke and remove the foot from the cavity in less than a T seal second. So ideally this corresponds to the frequency. So with reference to this frequency, like it has an impact, like it doesn't allow the lizard to move down. So instead of that, there is a kind of a periodic set which with an absolute minimum on the frequency, and the lizard must slap down to reach a kind of a higher order frequencies so that it doesn't allow it to sink. Okay, so this is the overall correlations. So these are some of the references related to this particular aspect. So overall, so in this module, so we had discussed a lot about the propulsion, about a biomimicking based propulsion on a macro level, slightly on a micro level, how the mechanisms are adapted from a naturally available system to the to the conventional system, and how it can be translated appropriately for micro robotic related application. As far as this water runner robot perspective point of view, so we will be discussing in detail with an application in the next upcoming module. Thank you.